Okay, here are solutions to the test we just took. So it looks like this, and I'm going to go through and explain how we got each of these answers. So first of all, this is a velocity versus time graph. The one down below is position versus time. Question 1 says, how far had the object gone in the first 2 seconds? So for a velocity versus time graph, we can find distance by the area under the graph. And by the area under the graph, we mean this sort of shaded area like this. So our first triangle, 1/2 base times height gives us 4. Our second triangle, 1/2 base times height gives us 4. Third triangle, 1/2 base times height gives us 6. And then this 1/2 base times height would give us 3. Okay, adding those up. Sorry, I'm thinking about question number 5. I went too far. Question number 1, so how far had it gone in the first 2 seconds? That would be 4 meters, and that's just how we ended up with this answer. You could also you could think about it this way. The velocity starts at 4 meters per second, and after 2 seconds, the velocity is 0. So the average between 4 and 0 is 2 meters per second, and it goes an average speed of 2 meters per second over the course of 2 seconds. So we would do velocity times time. The units of seconds would cancel out, yielding 4 meters, which is what we got here. Okay, so you can find area, or you can think about average velocity. You could even use the fact that the initial velocity is 4, final velocity is 0, time is 2, and do the VF square. No, you would need acceleration for that. Yeah, you'd have to find the acceleration from the slope, and it would be a little more involved, so never mind. Question 2. What was the object's acceleration at t equals 3 seconds? So that is simply the slope. Alright? Pay attention to the units here when finding slope. It changes by 4 meters per second over the course of 2 seconds, so we'd end up with a negative 2 meters per second slope of this line. Rise over run. 3. When was the object not moving? So most people had this between 7 and 10 seconds. That's great. Right here at t equals 2, it has an instantaneous velocity of 0 meters per second. So you would need to include that value in this solution to get full credit. Again, this is a velocity versus time graph. Okay? 0 velocity, 0 velocity. In what direction was the object going at t equals 11? So it has some positive value of velocity. Looks like about 2/3 of a meter per second. But if you said this, or if you said positive, or if you said to the right, those would all be correct. I like this spelling of what. Okay, 5. What was the total distance traveled? So here we are back at this, where we have calculated the area under each of these, and some people sort of did like a line down here and found the area. It's the area sort of with respect to the time axis. So 4, 4, 6, 3 gives us 17 meters. A lot of people just had a number and no work shown, and I don't know if they were guessing or what, but if you have the wrong answer and you don't have any work shown, it's hard to give you any partial credit. Well, impossible, actually. Okay, 6 to 10 refer to the following position time graph. So, let's see. Position time. So this is location, not velocity. The slope gives us velocity. Okay, so we go from negative velocity to positive velocity, negative velocity to positive velocity. Let's see what the questions ask. 6. How fast was the object going at t equals 4? So at t equals 4, it looks like right here we calculated slope by doing something like rise over run. So this looks like a negative 20 over 4 would give negative 5 meters per second. Now, it just says how fast. So technically that refers to speed. So if you just put 5 meters per second, that's perfectly fine. Again, speed is sort of like the absolute value of velocity. The direction's not actually included. 7. When was the object moving in the backwards or negative direction? So it has a negative slope and it has a negative slope. So there would be two regions between 0 and 8 seconds and between 12 and 20 seconds. Question 8. What was the object's total displacement? So there's a difference. I was about to say there's a distance between distance and displacement. There's a difference between displacement and distance. Displacement is the change in position. So your initial position and your final position. The change between those two. How far did you end up in relation to where you started? So this object or person or whatever starts at 40, goes to 0, goes up to 10, goes back to 0, okay, and then goes back to 40. So even though this person moved a bunch of distance, they ended up at the same spot that they started. So they started at 40, ended up with 40, or at 40. Their displacement was 0 meters. Question number 9, what was the object's total distance traveled? So total distance, 40, so they go 40, they go 10, they go 10, they go 40. Total distance of 100 meters. And for question 10, in real life, the graph wouldn't look quite like this. At what times would the object be experiencing a rapid acceleration? So here we have an object goes from negative 5 meters per second all of a sudden to instantaneously going, and this looks like 5/3 meters per second in the positive direction. I'm looking at the slope. So at this location, at this location, at this location, all right, the velocity is instantaneously changing from something negative to something positive. This would be like a ball bouncing on the ground, okay? When the ball bounces on the ground, at the bottom, it experiences a very rapid acceleration. The velocity goes from something negative to something positive in a very short period of time. So here, here, and here at t equals 8, 12, and 20 is where the object would experience a very rapid acceleration. And the reality is that the graph, if this were real life and we had accurate measurements, it would come down and sort of be rounded and rounded and rounded because the velocity would not change instantaneously like that. Okay, next page. So, matching, hopefully these were easy. This is stuff you definitely have to know. Time, position, distance or displacement, speed or velocity, acceleration, mass. If you didn't know that, please memorize it. And then, oh, you know what we could also say, this will be good information for you, is seconds measure time. Oh, wait. Never mind. All right, word problems. My favorite. Bowling balls dropped from the top of 20-meter building. Draw a diagram. So if you had something similar to this, this would be great. The height is indicated. There's something. It is dropping. That's good. Some people had these little dots, you know, indicating that it's sort of going faster as it moves along. That was awesome. Part B, list all the given information, explicit or implied. So the explicit information that's given is this, plus the fact that it's a bowling ball, but that doesn't really matter. We know that neglecting air resistance, all objects fall at the same rate. So this is the only explicitly given information. It is implied, one, that we are on Earth, so the acceleration is negative 9.8 meters per second. Ooh, shame on you, Tourville. Typo. Meters per second squared. All right. It is also implied that because the ball is dropped, the initial velocity is 0. Okay, so it's not thrown downward, it is dropped, and so it will speed up as it goes. But if something is dropped, you know that this information is implied. Okay. Some people just had d equals 20. Some people had d equals negative 20. You could be specific and say, all right, if the final position is 0, the initial position is 20. If you were to say, you could also say that the displacement is, that says displacement is negative 20 meters because it ends up below where it started. C, find the time it will take the ball to fall. So using this formula, the 1/2 at squared, we plugged in final position, acceleration is negative 9.8, initial velocity is 0, initial position is 20, solve for t, and ended up with, where is our value? Shame on me. I think this was... Hold on, let me refer to my sources here. Calculator. I thought I had this all planned out. Oh, I suppose I could pause. Okay, I'm back. Found a calculator, and after we solve, so we're solving this, we end up with something like negative 20 equals negative 4.9 t squared. Divide both sides by negative 4.9, take the square root, and the square root of 20 over 4.9 would equal t, which was about 2.02 seconds. Now, a ton of students did something like distance divided by acceleration, which is totally wrong, but 20 divided by 9.8 ends up giving you an answer that's very similar to this. That is sheer coincidence. Okay, this is totally wrong. Distance divided by acceleration does not give you time. This is the correct way to solve. Part D, find the speed of the ball just before it hits the ground. So here we don't know time. I mean, we actually do from the previous question, but assuming we don't, we would use this formula. Vf squared equals Vi squared plus 2AD. Substitute in initial velocity, acceleration, and displacement. Notice the negative here. Okay, it moved down, so it ended up below where it started, so the displacement's negative. Solving gives something like this. So if you had your answer as negative 19.8 meters per second, that would be perfect. If you said downward, that would be perfect. You could also say 19.8 meters per second and then just an arrow indicating you know it's moving downward. But to simply say 19.8 meters per second would not be correct because the direction is downward. For the experimental, if you had a graph and you labeled it, that was good. You got the question correct. If you if you found the slope and found an acceleration, and I think it was something like negative 9.6 meters per second squared for this data, then you got plus 5 extra credit points.